Okay, and we're back. This is the second video for week 6. We're going to move on to measures of central tendency. Okay, there's 3 main measures of central tendency. We've got the mean, which is sometimes called the average. We've got the median, and we have the mode. Okay, let's zoom in. So the mean, to find the mean for a set of numbers, you are going to add up all of the numbers and then divide by the number of numbers. So for example, if you have all of these numbers, you add them up, there's 9 of them, so you divide by 9 and you get 15. It says, note that the mean isn't a value from this original list, so 15 doesn't fall in here, or it's not found in here. This is a common result. Do not assume that the mean will be one of the original numbers. So the mean, you don't really have to have these numbers in any sort of order, you just need to add them all up and divide by the number of numbers. The median is a little more difficult. It's the middle number in the list of numbers, and it's a little more picky. To find the median, you have to put your numbers or sort them in numerical order from least to greatest. So sort first. Then, if you have an odd number of values, like 1, 2, 3, 4, 5 values, and you sort them and put them in order from least to greatest, an odd number of values, you're going to have the middle number is going to pop right out at you. But if you have an even number of values, 1, 5, 2, 10, 8, 7, 1, 2, 3, 4, 5, 6, and you put them in order least to greatest, you might have to fight between the two numbers. And when that happens, when you have an even number of values, you're just going to take the average. So 5 plus 7 divided by 2 gave us a 6. So 6 is going to become your median. It's not found in here. So 5 is your median here. 6 is your median there. Okay, mode is to find the mode. You don't necessarily have to have your numbers lined up in any certain order, but I think it's helpful if you do. So if you sort them and you take these and you sort them out, you have 13, 13, 13, 13, 14, 14, 16, 18, 21. Mode is the value that shows up the most often, MO, most often. If there's no number that shows up more often than any other number, then you just have no mode. You could also have multiple modes. You could have 2 modes, and that would be something called bimodal. You can have no mode, and this is all okay. Okay, let's see what's next. We're going to start off with finding the mean or the average. A group of 5 teenagers were asked how many hours they spent on their phones yesterday. Here are their responses. 5 hours, 7 hours, 3 hours, 6 hours, and 2 hours. Okay, find the mean or average number of hours for these students. If necessary, round your answer to the nearest tenth. Okay, so pause the video and find the mean or the average. All right, so if you're back, hopefully you added up all of these 5 numbers and got 23, divided it by the number of numbers, which is 5, and I got 4.6 on average hours spent on the telephone or the cell phone yesterday. So hopefully you got the same thing. Okay, same set of data, find the median this time. So it's still the same 5 teenagers, but this time we're going to find the middle number. First thing you want to do, remember with median, it's a little picky, is you want to sort these by least to greatest. So 2, 3, 5, 6, 7. Okay, this is an odd number of numbers, which is great. So you could say like, it's not you, it's not you, it's not you, it's not you, it's 5. So 5 is the median number of hours. So that's the number in the middle. Hours spent on phone yesterday. Okay, that was the median. Bet you they're going to ask about the mode. Yep, let's see here. Find the mode. Now remember, that's the number or numbers that show up more often than any other number. So we have 2, 3, 5, 6, 7. There isn't a number that repeats itself. No one stands out and says, I show up more often than others. So this is a no mode data set. Boring. All right, let's see what happens when you change the value in a data set. So how does changing a value affect the mean and the median? The weekly gross before taxes salary in dollars for 7 employees, 1, 2, 3, 4, 5, 6, 7, at Chick-fil-A are given below. Chick-fil-A. They have been ordered from least to greatest. Well, that was nice. Find the mean, find the median. Okay, let's find the mean first. So pause the video, add up all your numbers and divide by 7, and let's see if we get the same average salary. Okay, so hopefully you added up all these numbers and got $5,761 divided by 7 employees. And I'm getting an average gross weekly salary of $823. Okay, now let's find the median. Now, again, it's an odd number, so that's great for us. So we can say not you, not you, not you, not you, not you, not you. So it's 834. So notice how it's 834 is right in the center, it's the middle. We didn't have to do any fighting or anything like that, or any trying to figure out between two numbers what the average is to find the median. Okay, so we found the mean, we found the median. Okay, so suppose that the 1016 salary right here gets changed to 897. So they're gonna say this changes to 897. What happens to the median? What happens to the mean? Do they increase, decrease, or stay the same? All right, we're about to find out. Okay, so once we changed it to 897, that's gonna kind of shake things up a little bit. Let's see what it shakes. So I rewrote these out and replaced 1016 with 897. And now I'm going to add these all up and divide by 7 and get the new mean. The new mean. Then we'll find the new median. So feel free to pause the video, come back and see me. Okay, so with this new salary in here, I got $806 is the new mean. Hopefully you got the same thing. The median is still 834. That didn't change just because this number changed. So the new median is still 834. Okay, so what happened to the median? The median stayed the same. And the cool thing about the median is it is resistant to change. Okay, the median is that number in the middle. It doesn't care if you change this number or not. It doesn't care if you changes this number. It doesn't care if you change this number or this number or this number or this number. It only cares about what's happening in the center. So it's resistant to change. What happened to the mean? Okay, well, the mean was 823. Now it's 806. So the difference between 823 and 806 is it decreased by $17. There it is right there. So the median stayed the same. And it would make sense that the average would decrease because we went from $1,000 paycheck to a $900 paycheck. So that reduced our mean from $823 to 806. So it decreased. So the mean is not resistant to change. And that's because the mean or the average, it thinks about everybody's feelings, basically. All right, it thinks about all of the feelings or all of the numbers. It takes all of them into account, where the median doesn't care. It only cares about what's in the center. All right, we're going to look at what's called weighted mean. So weighted mean happens when you're trying to figure out your GPA at college or high school. And we're going to find it from a table. So the following summarizes the number of fiction books read last summer by a sample of 39 students at a certain college. So down here, it's 39 would be our total. And let's see if that makes sense. If we add 11 and 3 and 14 and 11, we should get, what's that, 22, 23, 24, 25 plus 14. Yes, we get 39. Okay. So this one, it's not a matter of taking the number of books and dividing by the number of books. We need to round our answer to at least one decimal place, but we need to think about it as, there's a couple ways you can go at it. There is like a strong arm way where you can say, okay, so 3 students read 1 book. So that's 1, 1, 1. 11 students read 3 books, so you can just keep writing that out. That is a total pain, and you're gonna have a very long set of numbers. So I think it's easier to go something like this. So we know we have number of students is 3, and each of them read 1 book, plus number of students 11, times each of them read 3 books, plus 14 students said they read 4 books, plus 11 students said that they read 7 books. And we're gonna divide that by 39 total students. So this might be the way to go instead of writing everything out. Because I really don't feel like writing out 11 threes and 14 fours and 11 sevens. Okay, so see what you can get, come back and see me. All right, so hopefully once you do your computations, I'm getting 169 over 39, which is roughly approximately to 4.3 repeating. They asked to go to 1 decimal place, so it's 4.3 is the average, or the number of books read on average. Okay, so this weighted mean from a table takes a little more time than regular just mean when you're just having your numbers written out, in front of you. But if you kind of shortcut it like this, I think you should be okay. All right, let's move on to the next topic. Okay, so we have reached approximating the mean of a data set given a frequency distribution. This is going to take a little bit of time, so hopefully you got your caffeine and your chocolate and you're ready to rock. You are ready to put your house on the market since you've just accepted a new job in another state. Looking to sell the house quickly, you're investigating various realtors in the local area. On their website, Home Realty displays the following frequency distribution, summarizing their selling time and days of the last 18 detached residential houses they sold. Okay, so selling time and days, they had 4 houses they sold between 0 and 10 days, 4 houses they sold between 11 and 21 days of being on the market, 7 houses sold between 22 and 32. So that's a month, right, of being on the market. A little over a month, we have 1 house that sold between these days and 2 houses sold within these days. Okay, they say based on the frequency distribution using this is midpoint, which we haven't done yet, of each data class, estimate the mean selling times of the houses. For your intermediate computations, or so while you're doing your computations, make sure to keep at least 4 or more decimal places going, and at the bitter end, round your answer to 1 decimal place. Okay, let's find the midpoint. We'll make another little column here. Midpoint. So this is kind of what you have to do when you're looking for your average and you're stuck with a frequency distribution chart, which is what this is. So just gonna have patience. We'll take our time here. Okay, to find the midpoint, you're gonna take that lower end of the interval and the upper end of the interval, you're gonna add them together and divide by 2. So 0 plus 10 divided by 2 is 10 divided by 2, which is 5. That's your midpoint. 11 plus 21, and add that together, divide by 2. That's 32. Cut in half, that's 16. So pause the video and find the midpoints of the rest of these. Okay, 22 plus 32 divided by 2. All right, so that's 54 divided by 2 is 27 is our midpoint. So you might be wondering, why are we doing this? Or you might not. If you're a procedural kind of person, you're probably not caring about that. But if you are wondering, what the heck are we doing? Why are we finding the midpoint? Or maybe you already know why we're doing it. It's because we're working with the frequency distribution charts. So we know that there were 4 houses that fell between 0 and 10, but we don't really know, was it 0 days? Was one of the houses at 1 or one of the houses at 2 days? We don't know. So we don't know in that interval, we just choose to use the midpoint. Okay, so now that you got your midpoints, you're going to use your midpoints and your frequencies and do just like we did in the last problem. So we have 4 houses And the midpoint we're gonna say is 5 days on the market. Plus 4 houses times 16 days on the market. 7 houses times 27 days on the market. I think you're getting the idea here. 1 house, roughly 38 days midpoint, and 2 houses. And I'm off the chart here, times 49. Okay, we're gonna put this all over. Remember they said there's our 18 houses in here. You can check that. 4 plus 4 is 8, 8 plus 7 is 15, 16, 17, 18. So there truly are 18 houses here. Okay, so we're gonna do this math and we're gonna figure it out and we're gonna come to 1 decimal place at the end. Okay, so if you did the math out, you would have gotten 409 over 18, which is 22.72 or approximately 22.7 days. That this particular realtor, what do they call it? Home realty, on average, so 22.7 days on average to sell a house based on the last 18 houses they sold. Okay. We are coming into the last few concepts here. You're probably pretty happy about that. All right, so what do I got here? Oh, finding outliers. Okay, on ratemyprofessors.com, Dr. Porcel received the following quality ratings. Identify all values that could be an outlier. Okay, what is an outlier? An outlier is a data value that is much smaller or much larger than most of the other values. It is unusual in size and very different from most of the other values. So it's kind of like a data point or points that have strayed, I call it strayed from the herd. Okay, so if you like animals and you think about animals in a pack, right? So you have like all these animals here, and then you might have like an animal out here. That's an outlier. It's strayed away from the pack. So if you look at all these ratings, and I just made these up, I am on ratemyprofessor.com. I just found out from someone told me that. So a 5 is a perfect score by student rating you, and a 1 is a not so great score. So I just threw some scores in here. So I got a 5, a 5, a 5, a 5, a 5, a 4, a 4, a 5, a 5, a 5, and a 1. So there is a number that could be an outlier. And if you're thinking the same thing I am, it's probably that 1 is or could be an outlier. So that could be a piece of data that has kind of strayed far away from these 5s and these 4s. Okay. So just look for some things that are unusual. Okay, what is the best measure of the center for data sets? When your data set has outliers, now this is just some notes that you should have with you. When the data set has an outlier, the median is the better measure. This is kind of like my little trick to help you. Why? Because medians, if you recall, are resistant to pesky, I said peskily, pesky outliers, okay? So when you have an outlier, sort of like if I go back to my ratings here, all right? So this 1, it's going to throw things off if I was taking the average here, because the average, of course, thinks about all the numbers. But if we put these in order from least to greatest, and we can go ahead and do that. So I put these ratings in order and define the median. You know, the median is 5, right? Median doesn't care about this bad score that I received. So when there is an outlier, it can skew the data and not really represent the data very well. Therefore, it can make the data seem a little misleading. How about consider these ages in years? 1, 2, 3, 4, 5 years old, 30. The mean is 7.5 years, but it does not summarize this data set very well. Why? Because we have this pesky outlier here. That 30 skewed that data and made those ages much higher than most of the ages there. So it doesn't summarize the data very well. But if you were looking for the median, so the median would be, so it's not this one, not this one, not this one, not this one, so it's a tie between 3.4 or 3 plus 4. So 3 plus 4 is 7 divided by 2 is 3.5. So the median, the middle number, is the better measure of the center for the data because it's resistant to that 30-year-old age. When the data does not have any outliers, so if you don't have any of those pesky outliers, then it's probably best to use the mean as your better measure of figuring out what is the center. So consider these two data sets. You've got 1, 2, 3, 4, 4, 5. If we add those together and divide, the mean is 3.17. The median is 3. So I had a little typo there. The median for this data set would be right in here, 3.5. And the same thing here, 1, 2, 3, 4, 6, 8, the median would be 3.5. Okay, so the median is fine, it's right in the center, but the mean might be the better measure of center because notice there's no outliers, there's no number or numbers that have kind of strayed away. So if we were just to compare the medians, 3.5 and 3.5, we would miss the fact that the second set of data has a greater value. Okay, it's got that 6 and that 8. Therefore, the mean, which is 4, is the better measure of center for this data set right here. And mean over here would be 3.17. So what they're saying is comparing these medians isn't going to be very helpful because the medians, are right there in the center and there's no number or outlier that's skewing the average. So in this case, use the average. So when the data set does not have any outliers, the mean is the better measure. And I think on project 2 or 3, you might be asked to give an answer about what you think might be the best measure of center. So come back to this slide to help you think that through. Okay, we have one last one, I think. Oh yeah, what is the best measure of the center below all the ages of all of the students in a kindergarten class? Okay, so the first thing you want to look for is there any outliers? So we've got 5-year-olds, 6-year-olds, and 7-year-olds, right? So there is no outlier. Like you don't have a kid who's like, let's just say, 10 in kindergarten, or a kid that's like 3 in kindergarten. You don't have any outliers here. So because we do not have any outliers, let's go back to our Danny cheater set. When the data does not have any outliers, you might want to use the mean. Why? Because we might miss the fact, in this case, they're comparing two data sets, but for our purposes, the mean is going to be a better measure. And let's type out or write out why. So because we have no outlier, there's no outlier out there to skew the data. So the mean is going to be your best measure. Okay. There is definitely no outlier in these ages of the kids in this kindergarten class. So it's safe to use the mean and add all of these ages and then divide by the number of kids, and that would give us an average. Probably it's going to be somewhere around 5 or 6.5 years old. Okay, that is it for week 6. If you're in the online section, I'll see you next week, or the online live section, I'll see you next week. If you're in the online section, feel free to give me a call or email me. I'm here for you. Bye for now.